Okay, number 10, page 34. And graph of a function of the form square root of a function. So we're going to graph fx, then we're going to erase the part below the x-axis because the value of the function below the x-axis is negative and we cannot find in the real number system the square root of a negative number. Also, we need to note that the square root of fx, its derivative, is f dash x on 2 times the square root of fx. So the intercepts of fx are critical points of y equals the square root of fx. So if fx does not equal 0, the stationary points of f dash x are stationary points of the square root of fx. If the function is between 0 and 1, then the square root of the function is bigger than the function. So the square root of a fraction is bigger than the fraction itself. If the function is bigger than 1, then the square root of it is less than the function. Okay, so let's have a look at the example down the bottom here. Sketch y equals square root of cos x. Well, we first of all can think about where's it going to cross the x-axis. Well, it's going to cross the x-axis each time that cos x crosses the x-axis. So that's these points here. We can look at the derivative. So let's do that. The derivative well, we've got the function equals cos x to the power of a half. So the derivative will just equal sine x on 2 root cos x. Oh, it's going to be a negative. So cos x cannot equal 0. The derivative equals 0 when sine x equals 0, which is, think about sine x, it's 0 there, it's 0 there. And of course it's 0 there. Okay, so finally, dy dx is undefined when cos x equals 0. So that means that we're going to have some perpendicular tangents. So it's not allowed and it's not 0, it's undefined. So that means it's a straight up and down. So you can investigate this a little bit further, but we're going to get these strange little shapes that are basically, I don't know what's going on here, that should be a 1. Circles or semicircles. Like this. Okay. That's it for page 34. When we return first week, we'll get on to part 11 using implicit differentiation. We'll spend a lesson on that, and the last part, which is inequalities.